So hello everybody. Yes, so the actual topic and objective of this talk was to convince the systemd maintainers that event logs are important and systemd should manage them. But as I learned yesterday, Leonard seems to be on board with the idea, and I'm done here, right? So enjoy the rest of the conference. But maybe some people can learn something new about event logs and how remote attestation looks in practice. So I'm Kai, and I'm currently working for a company called Niche Systems. I previously had a company that did firmware security, mostly for servers and endpoint, and part of that security was doing remote attestation to figure out, okay, is there anything in the firmware, for example, that could look like malware, right? And we did this using TPM, right? And aside from that, I'm more from the security side of things, like doing cryptography, static program analysis, stuff like that. So TPMs, I guess everybody knows what a TPM is by now. For those who don't, like this little chip on the board that collects measurements. During our boot phase, right, every component of the boot phase does some measurements of the next component, sends it to TPM, TPM keeps it there in some combined hash, and later on we can ask TPM, hey, give us a signed statement or these PCR values, right, these hashes, and then I can look at the PCR values. If they are in my whitelist, I can say, okay, I know what code and data has been consumed during the boot, and by induction, I know the state of the system, right? That's the basic idea. And yeah, there are like a bunch of components, firmware components, like from the ACM, which is like super early, Intel signed blob that boots, up to UEFI, tboot, if you're doing like DRTM stuff, GRUB, or if you're booting your system with UKIs, like you all should, then systemd stub is measuring stuff. And then, like we learned a few seconds ago, systemd also does some other measurements, and then there are things like IMA and your application, right? So your application could also measure stuff in there to help it to secure the system, right? And yeah, so these PCR, they are all numbered from 0 up to 23, I think. And yeah, the problem is, the basic idea is that depending on which PCR index you have, there are certain parts of the system in there, right? The thing is that they're a bit over-allocated, right? So PCR 0, for example, which should contain like the basic firmware stuff, contains a lot of other stuff. For example, the option ROMs, right? This is the code that during boot is just loaded from your PCI card and then executed to do something. And this is all in there, right? And this kind of creates a problem for remote attestation. Luckily, there's this event log type thing. So every time one of these components does a measurement, it sends it to the TPM. It also has its own event log where it puts an entry in there that tells us first, okay, which PCR value did I use here? What is the event type, which is an integer that should tell you roughly, okay, what is this measurement about, right? Where does this hash come from? Then the hash itself and the event, which is some meta information that is event type dependent that ideally would allow you to recover this measurement, right? In the best case, this is literally the blob that has been measured and sent to TPM. In practice, it's often some kind of pointer, right? So for example, ACPI tables are measured, and there you only have the pointer, so the physical memory address where the ACPI tables were during boot. So if you want to recover that, you have to like fish it out from physical memory, measure it, and see if that matches up. It's kind of a mess. And yeah, so if you got this event log, right, you can go through the event log and do the same operations that TPM does, measure them all by PCR, and then the idea is the PCR values you recover are exactly the ones that you get from TPM, right? The problem comes when you look at this in practice, right? So for example, not all measurements come from the CPU itself, right? It's not just what's on the flash itself, but you also have peripherals that on x86 systems, they are their own computers, right? And they have their own runtime measurement architecture in there. So for example, the Intel CSME, like ME, the thing that the NSA uses to spy on us, they have their own runtime measurements in there. They do this during boot, and then during the boot of the host CPU, the UEFI asks the CSME, hey, give me your measurements, and these are put into like the general system log. Same with PCI devices, like graphics card, for example, they have their own measurement architectures. And these are all put into the same PCR, right? So if you look at the specification, like depending on how the implementers feels like today, they put it either into PCR 0 or PCR 2. But they all put it in the same PCR, right? So imagine you have like two different firmware versions for each of those. maybe an old and a new one, then you have 4 combinations that are possible, right, in your data center. For PCR2, for example, if you're lucky. And this ignoring everything else that goes in there. Which means that in practice, if you want to do remote attestation, the core data structure you have to analyze is the event log, right? You have to recover the event log, analyze every little entry in there to figure out, okay, what runtime measurements has been sent for the CSME, which runtime measurements came from other parts of the system, what UEFI applications have been measured. Look at these individual, understand, okay, do I trust this stuff, and then recover the PCR values, get the quote from the TPM, and then see if everything matches up, right? Okay, so event logs are a good idea, right? We need that for remote attestation. And because they're such a good idea, there are lots of them. There's, of course, the UEFI like firmware event log that the UEFI takes care of. And all the measurements that are done either by UEFI itself or by UEFI applications, like GRUB, for example, they are all in this event log. And this is this thing you can get from sysfs, right, on the BIOS binary boot measurements. And this is like some TCG-defined binary format. But there are other things. For example, the BIOS ACM, like the super early code, that does measurements, but it doesn't have an event log. So the UEFI has to recreate these measurements and like prepend it to its own event log. Or you as a remote attestation framework have to know, okay, there are some invisible measurements that have been done before all of this and like put them in. If you do tboot, if you look at, for the people who know DRTM things, they have their own event log. So during the DRTM setup, the MLE setup, there are also measurements done. They are not used with, they are not put into UEFI event log because that runs after UEFI. In order to get that event log, you have to go through ACPI tables, find a pointer there that points somewhere into memory, and then fish it out using defmem or something like that. This is also using the binary TCG format. And then, yeah, like how I learned a few seconds ago, systemd also got its own event log using the JSON format somewhere on disk. Well, that's good for the TPM, for the systemd measurements. Then there's also IMA, which we will talk about a bit later, which also does measurements constantly, even during the system, while the system is running. There are actually 2 of them. There's like an ASCII and a binary version. You can also fish them out from sysfs. And of course, your application, right? So if you want to do your own measurements, if they're not like super static, you will also have to have some kind of event log just to debug stuff, right? And this is like pure chaos, right? You can do whatever format you want and where this is and so on. Yeah, maybe a short introduction to IMA. The idea is actually pretty cool. So effectively, the kernel, if you enable that thing, the kernel will, before any user applications consumes the file, measure the file contents plus some meta information into the TPM, in this case, TPM PCR 10, I think, and also keep it in event log, right? And later on, when you do remote attestation, you can recover all of these logs and first do a remote attestation to see if they have been manipulated or not. But if everything is fine, you can go through the log and see, okay, have files manipulated, for example, right? You can say, okay, the authorized keys file for my root user has to have this hash, right? Because there are only these 2 keys in there, and every change to that is like a security problem, right? So maybe some people remember Tripwire or like all these other host intrusion detection systems from decades ago. This is a bit like that, but a bit more secure because it's hardware backed. The problem arises when you try to do this actual remote attestation, right? Because, like we learned, you have to have the event log. So you read out the event log from the kernel, actually. So this is an append-only data structure that's kept in the kernel, in memory. You read that out. That takes a long time because it's a huge thing. And then you read the PCR values from the TPM because the quote doesn't give you the whole PCR set. It only gives you a hash over all of them. So you get the actual PCR values, and then you get the quote, right? And what happens in practice is that while you're reading out your like tens of kilobytes of event log, some other application starts somewhere else in the system, opens a file, IMA starts to measure it, and then you have like a new entry in the event log that you didn't catch. PCR values have changed. The quote matches the PCR values, but the event log doesn't, right? Because of this race condition. You can have the same thing between reading out the PCRs and quoting, but because of these options, their application, they are pretty fast, so that doesn't happen as often as the event log thing. So we have to have some kind of arbitrary broker system in between that helps us to make these three operations, right, an atomic operation, right? How do we do this? We had another layer of indirection, right? Of course, the TCG people already thought about that and came up with this huge thing called the AMBRD or something like that. It's like a daemon that does all the TPM management and like resource management and so on. The idea, the thing I'm proposing would be probably somewhere in the feature API part here. But yeah, if you look at the definitions of the thing, it's gigantic, and you really don't want that thing, right? I'm not proposing that. I think that the thing I'm proposing would be somewhere in the access broker, I guess, no, but no idea. So what I propose is that systemd gets a new daemon, very creatively called systemd-tpm, that exposes the dbus interface that has exactly two functions. The first one allows me as a user space application to measure things. I tell it the index, I tell it the type, right, the integer that gives it some kind of meta information, the digest of the data I want to measure, and some event metadata that I can later use to understand, okay, what is this event, right? And then it just measures it, right? And it puts it into the unified systemd managed event log. And then there's a second function that is called quote, and I give it a signer and session handle, so this is like TPM things. This is pretty much a handle to the key that should be used to sign this quote, plus some authentication thing. But I gave it like a PCR selection, a set of PCR I want to have quoted, and some extra data, which is some nonce that is put into this quote signature thing. And I get the quote, I get the signature, I get the PCR values, and I get the event log in one atomic operation. And systemd guarantees me that, like, as long as there's no attack on the system, the quote matches the signature, the PCRs match the quote, and the event log matches the PCRs, right? And I can look at this as a remote attestation. Go ahead.
So, does it work? Hello?
I can hear you.
Okay, so how would I, we can certainly do something like this. I'm sympathetic to this, but how would we do the atomicity of the quote? We can certainly start processing the event log until we find the PCR state that the quote is for, or is that how it works? Okay.
This assumes everybody goes through that interface, of course.
Well, that basically would mean that the quote is super expensive, right? Because you ask me for the quote, and then I have to look at the event log, calculate it, and find the right point to give it to you. I cannot just give you the event log. I would have to first match it up with the quote, right?
Well, if you make sure that the event log is not appended to while we're doing this operation, it should be fine, right? So the hardest part is blocking IMA from doing something.
Yeah.
But I think, so IMA is a surprising amount of code. I'm not saying I understand it. But I think you can block it by just opening the file descriptor and then won't be able to access the TPM at least. Because there's no resource arbitration between user space.
I thought it was using the TPM RM thing in the kernel.
Yeah, but if you try to talk to TPM, AMI will probably not be able to do it at the same time.
Well, but there's the resource management stuff in the kernel now, so we'll just swap it out, my stuff, and just do its stuff. Doesn't it?
Could be.
I think that's not going to work.
Okay.
But I mean, my personal interest in the IMA is limited, so I think it would probably be fine if I give you the rest of it, excluding the IMA stuff. But I'm just simply a little bit concerned about the quote because it's so expensive, because I have to analyze the stuff. I mean, it's not going to be expensive in the non-IMA case, because the measurements are going to be limited probably. But I don't even understand how this works with IMA, the event log is going to grow huge, and it's maintained by the kernel. So what's the strategy actually to... Yeah, but how does it work actually?
So I can probably contribute to that. So the IMA is only usable, in my opinion, if you define a policy. So it has a policy, and you can limit this kind of measuring or like monitoring of the operating system components, and limit it to security-specific parts of it.
But that basically also means you need to limit the lifetime of the system, right? Like you cannot leave a system on for 10 years because then all of memory will be taken by the event log, right?
They don't double the entries. They just update it. So if you just say, just measure like the SSH daemon, for example, it just is one entry all the time. On some point, it changes the hash in the log, so it's not growing the log too big. But it's, yeah, there's a feature for that anyway.
As I understand the code, it's a ring buffer. It's not literally append-only.
So we had to, we used to measure the verity in IMA in Azure, and then we had to disable it because we've just updated images too often. The memory was just going on.
I'm just basically making sure that I understood what you were talking about. But essentially what you're asking for in terms of the API is you want essentially a way to say snapshot the current state, and then you want to verify against the snapshot.
I would definitely love to snapshot the event log and make sure that nobody else appends to it and access the TPM while I'm doing that. And all TPM accesses at that point that I know of come from user space, except for one, right? Which is IMA. Right?
So how is this better than? So essentially, the systemd-tpm daemon works as a lock around the interface provided by the kernel. How is this better than just taking a log file in some agreed upon place?
Because he cares about the integrity of all of these things together, right? He wants that somebody already made sure that the quote is consistent with itself.
Yeah,
right.
But this is just code that you can run into user
like,
process.
Sure, I mean, everybody can do this, right? Like, I mean, I'm sympathetic to this because actually much of what this does is actually what my systemd-PCR log thing does. All I would have to give you is basically, with the exception of the quote, but for the measurement stuff and the thing, we have that code, so I kind of, yeah. What I'm concerned about is like the log file that we now keep. I maintain, like, it's append only, and I maintain a lock on it so that my components don't write incomplete records into it. We could certainly open that up that other people can write to it, but I'm always a little bit concerned about that they might not do this properly, right? Like, because the standard example is on Java, you probably cannot take a BSD file lock on something, right? So if we open this up and say, oh, by the way, we are welcome to write to this lock as well, you have to take a BSD lock, then they're probably not going to do it because they simply can't. And then, yes, which is why I'm sympathetic to this, right? Like, because it solves these things, and then it can also solve a couple of other things.
We have 5 minutes left. Do you want to take more questions, or do you want to continue with the It's up to you.
No, go ahead. It's interesting to have the questions.
Yeah, but I mean, like, just call flock or whatever around the right operation. This works.
Java program.
I mean, Java can spawn things, no? Okay, never mind.
I don't care about the implementation. I'm a user. Also, the same thing with the format that can be bike shredded by systemd people. I don't care as long as there's some specification. Yeah, and this is like roughly how it would look like, right? You have a daemon in the middle. It consumes all these logs, and I get some kind of bus there, right? What's maybe another thing is it would be cool if you could persist these logs on disk, right? Because it would allow us to fix some other problem that we have with remote attestation on Linux, which is resumes, right? So if you do an S4 or S5 resume, so suspend to disk and then boot back up, this is effectively in boot. But because we do not initialize the system completely, but get some state from disk, in order to do an actual remote attestation, I would have to have all the event logs up to the cold boot, analyze them all in order to figure out, okay, how was this like state I just got from disk constructed? And for this, it would be cool if you could persist these event logs. So this is how Windows does it. I stole that from some Microsoft documentation. The WBCL thing on the top, this is like the Windows lingo for event log. What they do is they put a serial number into all of these event logs to make sure I can order them correctly, and I know there's none missing. And then they deploy in like a signing key in the TPM and use that to sign all of these event logs. That's good, and I think this is like from a security perspective, that's great. but that's also a lot of work, right? So you have to provision that key. On Windows, you put it into a registry, and then there's some magic to provision it, and then I have to like do a signature verification and so on. I propose we first persist them, and we can later figure out how to secure that. I think this is a bit more complex than necessary.
But why wouldn't that thing that we store on disk just be the quote that you want from us with all the event log stuff that we have up to that point? I mean, it sounds to me like we should just the output of that function you ask for and store that on disk after each hibernation cycle.
Yeah, the problem is well, this is maybe an edge case, right? But the signing key is the question to me, right? Here I can give it any key, right? I have my own like self-provisioned AIK and can give you guys, please sign with this one, please sign with this one. I could have 2 remote attestation applications on there that have different AIKs, right? And at least what Windows does, they have their own like system AIK to do only that, right?
But we nowadays create keys and store them like the SRK, for example, automatically in systemd on boot. We could just create any key we want. We have that code and things like that. We can just make up one and.
Okay, cool, like great, let's do it.
Or we can just use the SRK, can we not?
SRK cannot sign, it only can encrypt.
Sure, then let's do that. I don't know. I mean, there's even specs for that, right? It's just that I don't want to read the specs.
Yeah, that's pretty much it. Maybe there are still some own questions, right? Where we put these TPM logs, probably not in journal D. What about the format? Like, I don't care. We can think well, there would be an option to say we like make the dbus interface more complex, or to say, okay, we can load keys there and so on, but there's a lot of code that would have to be written.
Can you tell me why you want this by the 2 handles? Why don't you just give me a blob that I then unseal in the TPM and then?
Yeah, the thing is, if you start exposing interface where I can load different keys via dbus and configure them and do authentication, this is like 80% of the TCG spec, right? You would have to implement all of that, right? For example, the session, there can be an HMAC session, can be an audit session, can be an encrypted audit session, can be a policy session.
Yeah, but I mean, we have all that anyway because we use it for disk encryption, right? Like we already set up a session, we already encrypt the session, we already pin the SRK, we already do all this. It's trivial for us to just reuse this, right? Like so, given that we have all this, why don't you just give me a sealed key and then I give it to the TPM and then ask for a quote?
Which key is it sealed against?
Sorry?
Where is it? What is it sealed against?
SRK.
Well, what we, for example, did is that we enwrote our own SRK that had, for example, like an ASCII label in there to make it unique. So we can use that as an identifier for a system while it's at the customer, right? So we had our own custom SRK, we had our own custom AIKs that also got labels and so on. And having just a generic AIK is fine for most applications, but I would prefer to have more control over what keys are generated, what are the parameters of them, are they ECC
but again,
or
like
RSA
I
keys
expected
and so
you
on.
could just give me a marshaled blob like in the thing, and then I just pass it. So you can create anything you want. You just have to give me the thing.
Yeah, sure, but it had to be if I want to have my own primary key like SRK with a label. And then I think you could build all this, but then you would duplicate like the TPM interface again in dbus. Right.
But it wouldn't be duplication because we do it for the disk encryption stuff, right? Like we set up the encrypted session, we set up the SRK, we set up all these kind of things. So for us, just reusing this stuff is like 3 lines of code.
Okay. What about the sessions, right? If I want to do use a policy session for the signing handle.
So I mean, yeah, I mean, we currently support PCR policy and the signed one and the explicit one, and we'll probably soon do like this thing that it won for the PCR log stuff. But anyway, and the pin-based thing, right? Like so, it's going to be like 5 or 4 different kinds of things. But the TPM2S maintainers, they have a library now how you can put together these policies and then serialize it to JSON or something. We'll probably add that too. But that basically and then there is this thing that the kernel, like James Bottomley added this concept where you can in ASN1 encode the policy and things like that. So I would expect that this is kind of eventually we don't even deal with the policies anymore. We use some library that the TPM, TSS people maintain for us. Until then, we probably will roll our own policies, but I think we'll cover just the ones that people care about, which is PCR, the other two. Anyway.
Okay, I mean, if you already link against the TSS, then there's not much.
Yeah,
much
we
to
do
add
heavily.
there.
I mean, for disk encryption, for
Right.
for all these kind of things. For the measurement.
No, I wanted to just say that the TPM TSS has best practices for this and all kinds of helper functions. Feature API is too high level for this stuff, but the enhanced API has stuff for like making an attestation key, making sure that it's endorsed by the endorsement key. Like all the infrastructure is there, and we should just use what they suggest, I think, and then we'll be fine. The eAPI, I think that's the one we are using. Yes. Yes, that is correct.
It's badly documented, and there are some parts where I believe I know it better.
I mean, that's the thing. Like, my assumption was that all these kind of things of setup stuff, that's a part of FAPI, and that's not what I want to use. But if you're saying this is an eSys or whatever the eAPI, then we can revisit this. I don't know. There seems to be a communication problem.
More questions? Going once? Going twice? Well, let's thank the speaker.